Okay. Start at the beginning, that'll help. Modeling with linear functions. Modeling means that it's a real world situation, so it's basically word probleming with linear functions. That's chapter 1, section 4. The nice thing with linear is it's a straight line. We're talking about y equals mx plus b. We got that right here. Okay, hopefully you're familiar with y equals mx plus b. We're going to do a little quick refresher on how to write equations using a given slope and a y-intercept, a slope and a point. If it's a point and a slope, you're going to use point slope. And if they give you 2 points, first use the points to find m, and then use point slope, which is right back up here. All right. Okay. To find slope is your m. Remember, that's y2 over x2 minus y1 over x1. Okay, that's the formula to be able to find slope. So let's try 3 of them really quick. Okay, we're going to put all these into y equals mx plus b. That's our goal. Okay, y equals mx plus b. So what I'm going to do is write down y equals, I'm going to leave a blank for the m, put my x, I'm going to leave a blank for the b. Now this first set of things, I give you m and I give you b. This is the easiest one. If they give you slope and intercept, to put it in slope-intercept form, it's nice and easy. You put in the slope. You put in the intercept. That's 4. Boom. Dunzy. Okay. So when they don't give you the intercept and the slope that it gets a little bit more tricky. Here, we've been given a slope and a point. If I go back and look at point slope, I got y minus y1 equals m times x minus x1. So I got y minus y1, something goes here, equals m times x minus something goes in there with the x. This is where I'm going to put y1, this is where I'm going to put m, this is where I'm going to put y2. Okay, I do it like this every time. I leave the little fill in the blanks and then I grab my information, I fill in the blanks. The m is 2, goes where m goes. Whoops, didn't want to do that. Then I put in, this is x, this is y. Those are the ones if you want to, okay? 5 goes here, 3 goes there. Then to put it in y equals mx plus b, we just simplify. So let's distribute the 2. Y minus 5 equals 2x minus 6. Then move that 5 over so it's y equals, that's our k, which is our b, 2x now minus 1. Goes there. Now the even hardest one, yes, I even said even hardest, is when they give you 2 points. When they give you 2 points, you need to find the slope so you can do point slope. So to find the slope, it's the difference in y over the difference in x. It doesn't really matter which one of these you call the first one and which one you call the second one. What matters is that the coordinates need to be together on top of each other. And it's y's on top, x is on bottom. Rise over run. You rise in the y, you run in the x. So if this is my y, I'm going to put 6. If this is my x, I'm going to put 7. If this is my y, I'm going to put 2. This is my x, I'm going to put 5. Those have to go together like that. It doesn't matter if we did 2 over 5, if we did the bottom one first, and then 6 over 7. It should still work out to be the same. Let's check. 6 minus 2 is 4. 7 minus 5 is 2. 2 goes into 4 2 times. My slope is 2. 2 minus 6 is negative 4. 5 minus 7 is negative 2. Negative negative makes positive. 4 divided by 2, still 2. Doesn't matter which one we do first. What matters is these are your coordinates. And your y is on top and your x is on bottom. Okay. Now, y minus something equals something times x minus something. We found the m to be 2. Plug in one of those coordinates. It doesn't matter which. I'm going to use the first one. 6 goes in for y. 7 goes in for x. Distribute. Y minus 6 equals 2x minus 14. Add your 6. Y equals 2x minus 8. Okay. Slope-intercept form, easy to do. Point-slope form, good, and it's easy to move to slope-intercept. Plug in the pieces that you need, distribute, move over. 2 points, a little harder. Got to find the slope first, then it's just a point-slope form. Okay. Now, writing a linear equation from a graph. So now we're going to go into the word problem part. And it's going to use those components. They're either going to give us the slope and the intercept, they're going to give us the slope and a point, or they're going to give us 2 points and we have to find the slope and then plug it in. So the graph shows the distance of asteroid 2012 DA14 travels in x seconds. Write an equation of the line and interpret the slope. The asteroid came within 17,200 miles of Earth on February 2013. That's really close. Might want to call those digger guys to come and save the day. About how long does it take the asteroid to travel that distance? Well, we got a couple of things that we're going to do in here. One, we're going to write an equation. We're going to interpret the slope, and we got to find out how long for that distance. We got a little graph over here on the right that tells us some information. X is time in seconds. Y is distance in miles. And we got a graph with a point on it, 524. We even know where it starts. When things travel in time, they always start at 0 because they haven't gone anywhere and it hasn't taken any time yet. So we actually have 2 points. We've got 0, 0, and we got 524. It's a weird comma. 524. We need to make the equation, but we need slope. I'm going to do the 24 one on top because I like subtracting 0. It's easy. So y on top, 24, x on bottom, 5. Y on top, 0, x on bottom, 0, which is 24/5. Now, you might say, Mr. Maggart, can we make that a decimal? You could, but rise over run's easier to read if it's a fraction because the top is rise, the bottom is run. We go up 24, we go run 5. So, y minus blank equals blank times x minus blank. My slope's 24/5. Okay, and I got 2 points to use. Which one should we use? I'm going to use 0, 0 because it's easy. 0, 0. Y equals 24/5 x. Boom, there's my equation. Okay, part 1 done. Interpret the slope. What does the slope mean? Okay, if I have 24 over 5, what does it mean? Well, that means that I go 24 miles every 5 seconds. That's my rate. That's what I'm doing. I'm going 25 miles every 5 seconds. That should be every, not ever. And lastly, I got to figure out how long does it take to go the distance. Well, distance is a y value. And so I'm going to plug that in for y. 17,200 equals 24/5 x. And then I got to get rid of the 24/5. Now, we never really divide by fractions. We stay, change, flip. So instead of dividing by 24/5, I'm going to take it and I'm going to multiply by 5 over 24. If I do it there, I got to do it here. 24. There we go. The 5 on top and the 5 on bottom reduce to 1s, so that eliminates that. The 24 on top, the 24 on bottom eliminates the 1s, leaves us with x. Now we just got to do this math over here. I got to multiply by 5 and then divide by 24. Okay, well, I'm going to let a calculator do that math for me. So 17200 divided by 24 times 5 is 3,583.3 repeating. 3,583.3 repeating seconds is how long it takes. It's 3,583 seconds. Now, if we divide that by 60, 59.7, sorry, 722222222 minutes. That's kind of a little bit more what we're talking about, but they gave it in seconds, so we give it back in seconds. Let's try another one. 2 prom venues charge a rental fee plus a fee per student. Okay. Per student means that's a rate, so it's going to be some number times how many kids. The table shows the total cost for different numbers of students at Lakeside Inn. So we've got a table of costs. The total cost Y in dollars for X students at Sunview Resort is represented by the equation. There they gave us an equation. Okay, good. Which venue charges less per student? So which charges less? We'll need to know what they charge per student each. And how many students must attend for the total cost to be the same? How many to be the same? How many to be equal? Okay, well, we're going to need 2 equations for that. We've got one equation. And how do we know what the charge is per student? Well, the variable in this is how many students go. So that's what the X is, right? X is the number of students. So if X is the number of students and there's a charge per student, the thing that's multiplying times student would be the cost per student. So this one charges $10 per kid and it costs $600 to rent the place. Let's get an equation for the other one. We need a slope. So I'm going to use the first 2 coordinates, 1500 on top, 100 on bottom, 1800 on top, 125 on bottom, negatives. Let's see, there's 300 difference here, and there's 25 difference there. Negative, negative goes positive. See, 25 into 300. Well, 25 goes 4 times into 100, and then there's 3 of those, so that should be 12. So, y minus something equals 12 times x minus something. And we're going to plug in a point. My y is 1500. My x was 100. Y minus 1500 equals 12x minus 1200. Move that 1500 over. Y equals 12x plus 300. So now we have an equation. This is the rate that they charge, right? Just like this one's rate. And this is the rental fee. This is the rental. So which one charges more? Sunview at $10 or Lakeside at $12? Lakeside charges more. Let's go back to the question. Oh, it didn't ask more. It asked less. Which one charges less? Well, Sunview charges $10 per kid. So Sunview is less at $10 per student. Then we have to say how many students must attend for them to be the same charge. Well, they both have a y. We can replace those y's with what they're worth. So we can say 10x plus 600 is going to be equal to 12x plus 300. And where are they equal? I'm going to move the 300. We got 10x plus 300 equals 12x. Move my 10x. 300 equals, that was a 3, I promise. 300 equals 2x divided by 2. X equals 150. So at 150 students, they're the same price.